Welcome to day 59. Today, we're talking about a classic idea in natural language processing called TF-IDF. It's a really clever way for machines to figure out which words in a text actually matter.
So think about it. When you type something into a search engine, it has to comb through millions, maybe billions of pages. Some words, like the, a, and is, are everywhere, right? But they don't really tell you much. So how does the machine learn to ignore all that noise and focus on the words that carry the real meaning?
Well, that's the exact problem TF-IDF was designed to solve. And by the end of this quick explainer, you'll get the core intuition behind it, how it measures a word's importance by striking a perfect balance between how often it appears and how rare it is overall.
To really get a feel for this, let's forget about the math for a second. Instead, let's use a simple analogy, a big library.
Just imagine every single document is a book, and our whole collection of documents is the library itself. A word's importance, then, is kind of like figuring out the main topic of any given book on the shelf. Now let's compare two words. Take the word the. It shows up a lot in pretty much every single book, doesn't it? It's frequent, sure, but because it's everywhere, it tells us almost nothing unique about any single book. Now what about a word like skydiving? It might show up dozens of times in one specific book about extreme sports, but you're probably not going to find it in most of the other books. That combination, being common in one spot but rare everywhere else, is what gives it huge informational value. It's a powerful signal about what that one book is truly about.
And this idea leads us to the first piece of the puzzle, term frequency, or just TF. It's super simple. It just measures local importance. It asks, inside this one document, how often does this word pop up?
The other half of the equation is inverse document frequency, or IDF. This is where we zoom out and look at the whole library. IDF measures global rarity. It asks, across all of our documents, just how special is this word? A common word, like the, gets a very low score here, while a unique word, like skydiving, gets a very high one. All right, so we've got the intuition down. We care about local frequency and global rarity. Now let's see how we actually turn that idea into a calculation a machine can use.
The formula for term frequency is just a straightforward ratio. You take the number of times a word appears in a document and divide it by the total word count of that document. This just normalizes the score, right? So a word that appears 10 times in a short paragraph is more significant than a word that appears 10 times in a huge book.
Now, the IDF formula can look a little scary, but the idea behind it is really simple. We're just dividing the total number of documents by the number of documents that contain our word. The +1 in the denominator is just a little trick to make sure we never divide by 0. And the logarithm, that's there to kind of dampen the effect. So a word that's twice as rare isn't treated as twice as important. It just scales things down nicely. All you need to remember is rare words get a high IDF score and common words get a low one.
Putting it all together couldn't be easier. We just multiply the two scores. The final TF-IDF score is simply the term frequency times the inverse document frequency. This simple multiplication is what rewards words for being frequent locally but rare globally.
Let's walk through a quick example. In document 1, the word science has a high term frequency. If science is also a rare word across our whole collection, its IDF will also be high. High times high gives us a high TF-IDF score. Perfect. Now, look at the word the in that same document. It also has a high TF. But because it's in almost every document, its IDF is super low. High times low gives us a low final score. And just like that, the algorithm highlights the important keywords and pushes down the noise.
Okay, so this isn't just some abstract academic concept. This is a real workhorse that's been used in countless systems for years.
You'll find it everywhere. It's a foundational piece of information retrieval, helping search engines rank pages. It's used for automatic keyword extraction, which is great for summarizing documents. And for machine learning, it's a go-to method for turning words into numbers, a process called vectorization, so that models can actually work with text data. So, let's bring it back to our original problem. When you search for skydiving, TF-IDF is exactly how the search engine knows that a page mentioning that specific word 10 times is way more relevant than a page that just happens to mention the word the 10 times. It quantifies relevance.
So let's wrap this up and boil it all down to one core idea.
At the end of the day, TF-IDF is all about finding words that are not just frequent, but distinctively frequent. It's looking for the terms that make a document stand out from all the others.
And that's really the one thing to remember. A word's true importance, at least to a machine using this method, is found in that beautiful balance, being common in one place but rare everywhere else.